Hello, everybody. We start with, let me check. Okay. Yeah, we start with circle equation. Circle equation. We have a circle like that and a center here and a radius A, and center is with H and K. A standard equation of a circle with a center, H axis and K coordinate, and radius A. We have x minus h square plus y minus k square is equal to a square. This is our formula for our circle equation. And you know, unit circle, not that, unit circle is the equation centered at the origin. I mean, center is 0.0, 0 axis and 0 ordinate, with radius 1. So we have x square plus y square is equal to 1. This is unit circle. Next, we will talk about interior and exterior of a circle. Now again, let's have a circle like that. And we have also again a center and a radius A. Let's say same point. And we have interior part like that, x minus h square plus y minus k square less than a square. This is interior part. And for the exterior part, we have again x minus h square plus y minus k square bigger than a square. This is the exterior. And of course, this one is the x minus h square plus y minus k square is equal to a square. Yeah, this line is a circle of the line, and this one is an exterior is here, and inner part you see here. Now, next subject is equation of a parabola. Y is equal to ax squared plus bx plus c. You know, a is different from 0, is a parabola. It opens upward if a is bigger than 0, that is positive, and opens downward If a is less than 0, this is a is negative, and the vertex is the point, which point I mean? This one. This is vertex, and this is vertex again for the parabola. Vertex is the point with x is equal to minus b over 2a, and y is found by substituting x minus b over 2a in the equation. What I mean, let's give an example. Y is equal to minus 1 over 2 x squared minus x plus 4. Let's say this is given. Find the vertex. And second question, find the opponent direction of parabola. Yeah. First of all, we know that a is equal to minus 1 over 2, and b is equal to, from here, minus 1, and c is equal to 4. It is seen like that. C is equal to 4. And we know that a is minus 1 over 2 is negative, smaller than 0. So opens downward. First question is okay. About the vertex, for the abscess one, we have minus b over 2a. So minus 1 over 2 minus 1 over 2. And this goes and minus here like that. Minus 1 is the answer for x. And to find y, we have to put this minus 1 for x. Sorry. Yeah. And minus 1 plus 4. What's that? Minus 1 over 2 plus 5. And it is 9 over 2. That is vertex is equal to minus 1 abscess and 9 over 2 ordinate. This is the answer of this question. And next subject is functions. Let's give a definition for function. A function from a set D to a set Y is a rule that assigns a unique single element, fx is an element of y, to each element of x, which is an element of D. Let's write this one. A function from a set D to a set Y is a rule that assigns a unique, maybe you can say single element, fx, which is an element of y, to each element x, which is an element of D. Yeah, this is the definition of the function. So what is important for functions? It's important to find the domain and the range of the function. First, domain of the function, domain of f, function f. Let's draw the Cartesian coordinate system again, and this is x and this is y. And let's say our function is like that. Our function is like that. This is y is equal to fx. Yeah, fx. And if we want to find the domain, we have to look at the shadow points of the function on x-axis. So what are the shadow points on x-axis? So here is the domain of f. So how can we find it? Shadow of the curve, that is, we have fx function on the x-axis. This is our domain. How can we find the domain? We can find the domain by looking the shadow of the curve on the x-axis. Yeah. Next one, range of f. Again, let's draw, first write it, range of f. And again, draw Cartesian coordinate systems. And let's say this is our function, y is equal to fx. And now, if you want to find the range, we have to look the shadow of the curve on the y-axis now, on the y-axis, not on the x-axis, but on the y-axis. So let's find it. Now we have to find the shadow of the line curve on the y-axis, like that, and it's going here like that. At the end, maybe here. So here is the range. Here is the range. So range of f. How can we find it? This is the shadow of the curve. On the y-axis. Yeah, these are important. Now let's give some example of domain and the range of some functions, some important functions. First, we have a general function mx plus b, which having slope m and intercept b. Here domain of f is equal to real numbers, and range of f is equal to, again, real numbers. You know, we have, this is true for all lines, What's that? What I mean by saying all lines? Such as, if we have a line like that with m1 bigger than 0, this means it is increasing. And if we have a line like that, which has a slope m2 and it is negative, this means it is decreasing. And maybe a line here, and this has a slope 0, you see, it's constant. So it is constant. Yeah. Yeah, this is like that. And next one. And another example, identity function. For identity function, we know that it is fx is equal to x. So again, we have range and domain. Domain of f is equal to real numbers, and range also, range of f is equal to real numbers again, because and we can say that this function is an odd function. Odd function. Let's say about something about odd function. Odd function means we have here 1, so this is odd function. If we have even numbers on the coefficient as a coefficient for x, I mean power for x, so this will be even function. So if a function is equal to fx is even function, and if this happens, this is odd function. Yeah. Let's write this one as a note. Okay. And you know that this line, identity function line, known that this is fx is equal to x, and this line is also known 45-degree line. 45-degree line. Yeah, here is m is equal to 1 and b is equal to 0 for here. No intercept, but we have a slope 1. Next one. The square function. I mean fx is equal to x squared. Here's the domain. Domain of f is equal to, again, real numbers, but range of f is equal to 0 closed, but up to infinity, so open end. And we can understand that this is like that on the real line, on the Cartesian coordinate system. So you see here is 2, so even function. And we can give the graph like that. For x squared, it's starting with like that, and it's going like that. We know that this is parabola, and we can find the range. By looking at the shadow on y. We said this before. So it is going like that. Yeah. Okay. Next one. Now we have cube function. Fx is equal to x cubed. You may easily find the domain. Domain is again real numbers, and range of f also real numbers. And we saw that this is odd numbers, so this function is odd. This is an odd function, and we can draw the line like that. This is abscess x, and fx. What is fx? Is here x cubed. So you can see that the range is again all real numbers. By the way, note that in our book we have some examples of range and domains. We also know this. y square, we write it, but again, domain is minus infinity and plus infinity, and range is from 0, closed end, and open end infinity, and y is equal to 1 over x, our function, and domain is minus infinity, open 0, and 0 to plus infinity. Our range is like that. And third one is x in square root and 0 infinity and 0 infinity again. And we have finally have 4 minus x in the square root, and we have minus infinity 4 in the closed end, and range is not 4, starting with 0 and infinity. And next one. Now, graph of a line, maybe of a function, but our function is a line now. Fx is equal to x plus 2. And to find the graph of this function, we are going to take 2 points. And connect each other. How can we do this? First, give x to 0. If you give this one, and y is equal to 0 plus 2, that is y is 2. That is, we have this point, and if you give x1, and you are going to find y, 1 plus 2 is this one, and here, and you may also give 0 to y, and if you give this one, you could find x plus 2, and x is equal to minus 2, and that is minus 2 comma 0, ordinate is 0 and abscess is minus 2. You may use these 2 points or whatever you want, and if you draw the line, this is x and y, and here minus x is here, minus 2, pardon, and 2 is here, that is, we have a line like that, and the other point, I mean abscess 1 and ordinate 3 is here, 1 and 3, this one 1.3, and this is the line which we want to find, that is fx is equal to x minus x plus 2. Okay, next one. If you want to draw a parabola, drawing a parabola, you can find also the points and connect each other, but we are using the general form of this one, so you have to know drawing x square. No, it's not good. X square is like that. But if you want to subtract some, such as, let's say, 1, you have to go on the line y, because y is subtracting as 1. So it is going to be like that. We are going to -1. Here we have vertex, axis 0, also y is 0, and now we have ordinate -1, so also as a vertex. So we are coming here like that, and if we have like that, x squared plus 1 or plus 2, whatever, we are going on that line on y-axis, and we can find that. Let's say this one is x squared plus 1, and say this is x squared plus 2. It's going like that. Yeah, for parabola, we have to know that, these things. Also, we can find the other points for the parabola by giving 0 again for axis and giving 0 to the y. And we can find lots of points, important points for the parabola and the function. And now this is piecewise defined function. Again, let's give an example for this one. Also, absolute value function is a piecewise defined function. So we can write it as x if x is bigger than or equal to 0 and minus x is smaller than 0. And we are going to draw the graph. When it is smaller than 0, I mean negative, it is minus x. You know that minus x is like that, decreasing function. Y is equal to minus x. Y is equal to minus x, this one. And starting with the point origin, it says when it's equal and bigger than 0. So it's kind of like that. And this is y is x, is our piecewise defined function. Maybe we can give a different example for this piecewise defined functions, maybe harder one. And this is the last example, by the way. And fx is equal to minus x squared, and 1. And minus x is if x is smaller than 0, and x squared when x is between 0 and 1, they are equal also, and 1 when x is bigger than 1. Now let's draw this one. This is, you see, when it is negative, x is negative, is x, you know, this is negative part. So when x is negative, it says y is equal to minus x. So here's fx is y, so y is equal to minus x. And when it is between 0 and 1 for x, and they are equal, it is x squared, a part of the parabola, and after 1, it says not equal to 1, so it is constant, and it is y is equal to 1. Yeah, this is constant, you see. So our graph is like that. It's decreasing first to the origin, then we have part of a parabola, then a constant function y is equal to 1. Now next lecture, we are continuing with composite functions. I want to say that, and we can remember this one. Okay, see you. Bye bye.